It's amazing how little we know about the inside of our own planet. We can't even agree on what's in the center of the Earth, though some say there's a giant ball of iron, and others say it's a big old donut. And it's not just us who have these problems. Scientists studying other planets have similar issues. Take Uranus, for example. It's been almost 30 years since we first observed its rings up close. And although we know quite a lot about them, we still don't know what's inside the planet itself. Back in the early 1980s, scientists thought that Uranus was mostly made out of rock and dust, like Mercury or Mars. But then later, they realized that it has more in common with Jupiter and Neptune, which are called gas giants. They're mostly made out of hydrogen and helium. But over the last couple of decades, researchers have started to think that things might not be so simple. Uranus could be something totally different from anything we've ever seen before. It could be an ice giant, a planet so cold that it's got water, ammonia, and methane in their solid form. And today, we're going to talk about what that would look like, and what it means for the planet's interior structure. First, let's get back to basics. When Voyager 2 flew by Uranus in 1986, it revealed that the planet is about 51,000 kilometers in diameter, roughly 4 times larger than Earth. If you tried to squeeze Uranus to make it the same size as Earth, it would weigh 14 times more than our planet. The majority of its mass is probably made out of gases like hydrogen, helium, and methane. That much is pretty similar to Jupiter and Neptune. But unlike its heavier cousins, Uranus rotates very fast. As a result, it's wider at the equator than it is tall. In fact, if you laid the planet on its side, it would be about 53,000 kilometers long. But why does this matter? Well, planetary interiors are always in hydrostatic equilibrium. This just means that all of the forces within the planet are balanced. Gravity pulls everything towards the center of the planet. But because Uranus rotates so quickly, centrifugal force pushes stuff away from the center. As a result, the planet isn't a perfect sphere. It bulges at the equator and is slightly flattened at the poles. For Uranus, this bulge makes it about 3,000 kilometers wider at the equator than it is at the poles. That's enough room to fit 2 of the Rocky Mountains end to end. Now, when Uranus formed 4.5 billion years ago, it also rotated quickly, but not as fast as it does now. Something caused the planet to speed up. But what? No one knows. Some scientists speculate that a large moon crashed into Uranus and knocked it off balance. Others say that it absorbed a smaller planet that spun really fast. Either way, whatever happened, it left Uranus with angular momentum, which is the tendency of an object to keep rotating. This is important because when Uranus formed, most of its mass was probably in a hot, dense gas state. But as time went on, it started to cool down, and as it did, different materials reached their freezing points and turned into solids. These layers built up on top of each other, creating an icy mantle around a rocky core. But how thick is this ice layer? That depends on how quickly Uranus cooled. And how quickly it cooled depends on how fast it's rotating. The faster it rotates, the less dense it is, and the thinner its icy layer would be. And according to some models, Uranus could have spun so fast that it doesn't have an icy mantle at all. Now, none of these scenarios paints a complete picture. There are several others that involve complex interactions between Uranus's atmosphere, its interior, and its magnetic field. So in reality, we don't know exactly what's inside Uranus, but we do know that somewhere in its middle there's a core. There are 3 main ideas about what this core is made of. The first is that it's made of rock. Now, this seems pretty straightforward, but scientists still have some questions. For example, if the core is made of rock, then how big is it? And if it's small, then where did most of the planet's mass come from? According to researchers, the core could be anywhere between 1,000 and 6,000 kilometers in diameter. That's as wide as the entire country of Brazil, or as narrow as the Strait of Dover, which is between England and France. The second idea is that the core is actually a giant ball of iron. Planetary scientists once thought that Uranus had a bunch of iron in its center, because they detected a strong magnetic field around the planet. Back in the 1990s, they realized that you can generate a magnetic field by placing a charged sphere on a rotating convecting fluid. In this case, the charged sphere would be an iron core and the fluid would be a layer of electrically conductive hydrogen. So based on its magnetic field alone, Uranus could have an iron core. But when Voyager 2 took a closer look, it didn't find any evidence for it. Today, scientists still aren't sure what generates Uranus's magnetic field, so having an iron core isn't really necessary. The third option is that the entire planet is a liquid, meaning that there's no solid core at all. In this case, Uranus would be similar to the gas giants, Jupiter and Neptune. But like I said earlier, Uranus is significantly less massive than them. So if it's mostly liquid, then it's probably not as dense as Jupiter or Neptune. Instead, it would be similar in density to water. But how could a planet be mostly liquid without being as massive as Jupiter? Researchers think it might have something to do with the material the planet is made out of. You see, if Uranus is made out of exotic ice, then it wouldn't have to be as massive as Jupiter to have the same density. Water ice has a density of about 917 kilograms per cubic meter. But if it's squeezed under extreme pressure, it can become hundreds of times denser. For example, ice on Earth can reach a density of 1.3 grams per cubic centimeter. The ice on Uranus would need to be a bit less dense than that, but it could still be thousands of times denser than regular water ice. So what does this mean for the inside of Uranus? Well, it could have an icy interior, a rocky core, a metallic iron core, or even a liquid core. Honestly, we can't rule any of these options out just yet. To understand why, let's take a quick look at how we study the insides of planets. Basically, we smash light into them. Whenever a planet is hit by a photon, it gets absorbed and re-emitted in a random direction. The only problem is, you can't tell where that photon came from, and therefore you can't tell what part of the planet it came from. But that's not true for every wavelength. For example, in the 1970s, astronomers found that the surface of Venus reflects very little ultraviolet light. They used this information to conclude that there is a layer of sulfuric acid clouds 50 kilometers above Venus's surface. Similarly, when Voyager 2 studied Uranus, it found that it reflected very little ultraviolet light. So scientists thought that it, too, had a cloud layer. But then in the 1990s, ground-based telescopes started detecting Uranus's reflected light in the infrared. Astronomers could then analyze the spectrum of this light to find out what chemical elements were present. They found methane, of course, but also hydrogen and helium. Based on this, scientists thought that Uranus looked just like Jupiter, Saturn, or Neptune, a bunch of gas and a tiny rock core. But in 2011, the Spitzer Space Telescope started looking at Uranus in infrared. Again, it detected methane in the planet's atmosphere, but it also detected something else: water, ice. And this wasn't just a one-time thing. Over the next few years, other telescopes around the world kept seeing Uranus's water ice. So today, scientists think that Uranus is covered in ice crystals similar to Earth's clouds. And because these clouds reflect so much light, it's impossible to look through them and study the planet's interior. That's why scientists are turning to computer models to help them figure out what's inside. By combining data from Voyager 2 with the new observations of Uranus's ice, they've created a few scenarios that could explain what's happening on the planet. The best one right now is that Uranus has a rocky core surrounded by a liquid layer made out of exotic ice. But it's possible that the core is liquid, too. Honestly, there are so many possibilities that scientists will just have to wait until we can observe Uranus up close again. In the meantime, if you want to learn more about exoplanets, check out this playlist right over here. Thanks for watching, and I'll see you next time.